Everyone, is this working? Good. Welcome to CS61B, Data Structures. I'm Jonathan Shuchuk. I'll be teaching you this semester, and here up I've put some information for you about the course, including my email address, but it's my preference that you not use the email address except for really private things. For general questions about the course, about subject matter you're learning in the course, how to use the compilers, etc., anything that you can make public. There is a Piazza board for this course, which I consider to be required reading, and I ask you all to put questions there if they're appropriate. If there's something you want to keep private, then you can send email to me and all of the teaching assistants at once by mailing it to cs61b@corey.eaks.berkeley.edu. And if there's something that's really private, or stuff like a sickness, for instance, that should just go to me, then and only then use jrs@corey.eaks, and that email goes to me alone. What else to say? I've put up a reading on the board for you. I'll talk about the required textbooks and readings in a minute. There is a web page for the class. You should all check it out. Oh, and I forgot, I have a handout. Let me grab that and bring it to you. I want to recruit a few people to hand these out, please. Can you please do me the honor? And you, sir? Good. Random. So please make sure you get a copy of this handout that's going around. It is the course overview, and it includes all of the policies for this class that hopefully will answer most of the questions you would have this semester. I'll go over some of the policies in the course overview today. And there will be some extra copies here on stage for people who want to grab them later. So let me start with the labs. The labs start tomorrow. Most of you are assigned to a lab on Telebears tomorrow or Friday. At least at the start of the semester, I'd ask you to please attend the lab that you're enrolled in on Telebears. We have a lot of people here, and so it's going to be tricky getting started, and to keep things organized and to keep the TAs sane, I'd like to request that if you're enrolled in a lab on Telebears, that you attend that lab at least for the first 3 weeks, with one exception that I'll talk about in a minute. Now, some of you are not enrolled in a lab yet. If you're not enrolled in a lab, it's probably because you're on a waiting list for a lab, or maybe you're a concurrent enrollment student and haven't been able to opt for a lab yet. If that's the case, then what you should do is simply try a lab that fits in your schedule, go there, ask the TA whether or not he or she has room for you, and they have the right to say yes or no. If you're not registered in their lab and there's just too many people trying to get into their lab, they might say no. But if they have space for you, they will let you into their lab, and you can cruise with them until you get admitted to a lab officially. But you should keep trying to get admitted to a lab officially on Telebears, and when you do get admitted to a lab, please attend that lab. One exception, though, I am going to allow students to swap labs. If you can find a person in another lab who wants to swap with you, you want to be in their lab, they want to be in your lab, then here's how you can make that exchange. First, find the person. You both have to be officially enrolled in Telebears in the labs you want to swap. Then send an email, and this email has to go to 4 people. You, the person you're swapping with, and both of the TAs of the 2 labs that are being swapped. And the TAs, again, have the right to say no, but usually they'll say yes, because they're going to have the same number of people in their labs. One reason why it's important to attend the lab this week is so that you get an account. And you'll get your account in lab, and you'll need your CS61B account to turn in homeworks, to run the program that submits homeworks. And the first homework is going to be due next week on Wednesday. Discussion sections, as you've probably already noticed, we didn't have any discussion sections this week. They're going to start next week, Monday through Wednesday. About the prerequisites for the course, the prerequisite for 61B is either 61A or E7. I think that if you don't have the prerequisite and you take 61B, you might get away with it. But please be aware that one thing you are expected to know before you take this class and have mastered is recursion. Recursion is a pretty hard topic. If you don't know it and you're trying to start 61B without knowing recursion, you're going to have a hard time. Also, some of you who have taken a data structures course at a community college or someplace like that might be able to skip 61B or at least skip part of 61B. So if you've taken a data structures course, but you have not learned Java or taken a course in Java, then there's a short course called 47B that we teach. It's a self-paced course. It just teaches you Java, and you may be eligible to opt out of 61B and just take 47B instead. If you've taken a data structures course in Java, or you've taken a data structures course and a Java course, you might be eligible to opt out of 61B altogether. To find out whether you're eligible, the person to see is Brian Harvey in 781 Soda Hall. And that information, again, is in the course overview that you've been handed out. So let me show you the textbooks for the course. We've got 2 textbooks for the class and 1 reader. The textbooks, one I require, one is optional. The required book, part of the reason I made it required is because I think it's a really good book, and it's pretty cheap by the standards of textbooks. It's not actually a textbook. It's meant for working programmers, which may be why it's such a good book. It's called Head First Java. It will teach you Java very well. It's one of the best technical books I've read. I think the writing style is really good and really effective. There are 2 editions available, and either edition will do. There are readings given for you on the class webpage, which are written out in terms of the 2nd edition. So it's easier to follow the readings if you have the 2nd edition. But if you have the 1st edition, I have taught the course in the past with the 1st edition, and if you can find the old web pages, I've got archives of every time I've taught this course. If you can find the old web pages with the old, back when I was using the 1st edition, that will give you the page numberings for the readings in the 1st edition. The 2nd textbook is an optional textbook. This is a textbook on data structures by Goodrich and Tomasia called Data Structures and Algorithms in Java. And this is, well, the 6th edition was just released by the publisher a few days ago. I don't even have it yet. Since it wasn't available till a few days ago, I'm making the 5th edition the semi-official edition of the course, but really you can use any edition of the book except for the second edition. The second edition omits 2 key data structures we're going to learn this semester, so I don't recommend you buy it. I recommend get any other edition. Even the first edition has these data structures. They left them out of the second for some reason, but then they brought them back for the third, and ever since. Again, the readings on the class webpage will be listed in terms of the 5th edition, because that's what's available as of the beginning of January. Oh, and a lot of students in the past have gotten by without this, just with my course notes, and it's kind of an expensive textbook, so that's why I'm making it optional. But nevertheless, I still think it's worth buying because when you read about data structures 2 different ways, my way and their way, you're a lot more likely to really understand them more deeply than if you just read my version of things. Finally, there is a class reader that you should purchase, and this is available at Vic Copy, which is on Euclid Street near the corner of Hearst, so very close to Soda Hall. And the course reader, about 2/3 of it is old exams from my 61B classes. And the best way to study for the exams in this class, by far, is to buy the reader and do all the old exams. So that's why the reader is mostly just old exams. I tried not to puff it up with unnecessary stuff that you wouldn't use, but there is one other thing in here besides the old exams, and that is a little bit of information on how to use GNU Emacs and the compiler and the debugger. And so the front part of the reader is stuff that you should take with you when you go to lab or whenever you go to do your homeworks or program, because it's the information you need on how to use the software. But that's a relatively small number of pages. Mostly what you're paying for is just the old exams. The old exams are not going to be made available electronically. The only way to get them is to buy the reader. And again, that's Vic Copy, V-I-C-K. Euclid near Hearst. Are there any questions before I go on to grading? Yes?
Online, I saw a link to the course reader, but it's online, so is that just the only info about just the Emacs and like debugging compiling stuff? Is that all that's provided?
Yeah, there is an online reader, and it contains the instructions that are in this reader, and it also can contain some additional instructions as well for other bits of software. It does not contain the old exams. So if you want the old exams, you have to go to Vic's. But I think they make it pretty cheap, so. Yes?
Does the reader include the solutions to the exam?
The solutions actually are online. So to find the solutions to the exams, you go to the class webpage that the URL was up a second ago. And from the class webpage, there is a link called Exams. And that exams link, well, it doesn't actually take you to exams, it takes you to the solutions to all the old exams. Other questions? Of course, I think the best way to study for the exams is to actually try to do them before you look at the answers online. But the answers are there online so that once you're done, you can check your work. So let me tell you a bit about how the course will be graded. It's going to be half exams and half assignments. And the assignments are labs and homeworks, including 3 large projects. And so it breaks down like this. There will be 10 points for the labs out of 200. So that's 5% of your grade. There will be 20 points for the homeworks. But really where you should put a lot of effort is on the projects, which are going to be worth 70 points. And then That's 100 points. The other 100 points are the exams. Half of that is the final, and the rest is divided between 2 midterms. So there will be 25 points for midterm 1. And 25 more for midterm 2. And 50 for the final exam. And you'll be able to look up your grade at any time through your CS61B account by using the GLOOKUP program online so that you can see how you're doing as the semester progresses. And to get an A+, essentially 185 or more points out of 200 is the threshold for that. And then from there on down, it's in increments of 10 points per grade rank. So for instance, if you get between 175 to 185, that's an A. 165 to 175 is an A-, and so on. The rest of the chart is in the course overview I've given you in a table, I think on page 5. So you can follow that if you want. The way I'm going to do the projects is that the first project will be an individual project, just to make sure that everybody really knows how to program. And then for projects 2 and 3, we're going to do group projects. Part of the purpose of CS61B is to teach you how to create very large programs, larger than you've done before. And so having a group project is a good way to learn software engineering and how to write code so that somebody else can write code, you can put your code together with their code and have something bigger than either of you could do alone. I want to say a few words about cheating. So if we find cheaters, then of course, we will report them to the Office of Student Conduct. There's also some information in the course overview about how we score that. And typically what happens is if you're found to be cheating on a project that's worth 30 points, then I'll assign you a score of minus 30 out of 30 on the project, which will definitely bring you down a few letter grades, and in addition to not getting any points on the project. If you do it twice, it's an automatic F. If you do it on an exam once, it's probably an automatic F, though I reserve the right to change my mind about that. The most important thing to understand, sort of for day-to-day living, though, is what I call the no-code rule, which is you are actually encouraged to help each other with understanding the concepts in CS61B, in understanding even things like how to program or how to interpret compiler error messages. But what you should never do is you should never have another person's code, like code written by another student in the class, in your possession at any time, nor should you ever allow another student to get possession of your code. Either one of those is considered equally bad. Giving someone your code is just as much cheating as stealing somebody else's code is. There is one exception. I'm going to call it the one-line exception. And I have a very specific request here, which is that during the semester, no doubt you're going to have programming assignments where you're fighting with the compiler and it's giving you an error message and you don't understand why, and you'll want to ask a question on Piazza to say, why am I getting this compiler error message? When that happens, please give us a cut and paste of the entire error message, including the line of code. including the line of code that's giving you trouble. Because if you don't do that, it's just impossible to figure out what the problem is. Yes?
So if, for example, we have some sort of complex interaction between a couple of lines we don't think is suspicious, can we make a post on Piazza that's private just to PA the professor?
You can do that, yes. You can use private posts to ask us about your code. I should mention that it's quite common in like previous times I've taught the class, students will send us big chunks of code and say, it's not working, help me. And sometimes we'll help you and sometimes we won't, depending on how much time we have, because big chunks of code take a long time to debug. Yeah? No. So your project partners can be anybody in the class. They don't have to be in the same section as you, the same lab as you at all. Just if you got a friend in the class, they can be your partner. And your partners for Project 3 don't have to be the same as your partners for Project 2 either. Other questions before I go on? All right. Why are we here? What is the goal of CS61B? There's 4 main goals, I would say. The course is called Data Structures, and we're going to learn how to understand, analyze, and program efficient data structures and algorithms for getting things done. What does that mean? Data structures are a way of formatting data in a computer so that you can ask questions and get answers fast. So, for instance, if I have a database of all 10 billion CDs that I own, and I want to know if there's a song in there called Wherever, then do I have to go through all 10 million records and search each one for the song title? Or can I structure my data in a faster way so that when that query comes up, I can check really quickly? Well, you can, obviously, computers do that kind of search all the time, and they do them really fast. You don't have to go through all billion items of your CDs to know if there's a title of a particular title, if you have structured your data in the right way so that those searches are fast. And we're going to learn how to do that. Another thing we're going to do is learn to write programs that are a lot larger than we have before. So the 61B projects are bigger than the stuff you did in 61A. And of course, the group projects will allow us to make even bigger programs. In order to learn how to do that, we're going to learn a little bit of software engineering. In particular, we're going to learn the concept of data abstraction. And we're going to learn how to define interfaces that allow one program to call another, one procedure to call another, one method to call another. The big idea here is if you're programming part of a project and your partner is programming part of a project and your other partner is programming yet another part, you need to be able to design your 3 parts so that when you bring them together in the end, they will work together correctly. That's not easy. That's actually quite difficult. And so we're going to learn how to think about designing the interface between 2 different pieces of software, the one you write, the one your partner writes, so that when you put them together, they'll be effective and work as anticipated. And this will give you the power to work in groups and build larger programs. In fact, it'll give you the power even when working just with yourself to build larger programs than you could have otherwise, because you'll have an architecture for your system that will support everything you want to do. And the fourth thing we're going to do in 61B, and this is kind of the most trivial thing we're going to learn, but it is going to take some time, is we're going to learn the Java language, and we're also going to learn about object orientation, because Java is an object-oriented language, and a good chance to understand more deeply how object orientation fits with point 3, which is data abstraction. Any questions about that? Yeah. There's no computer software that you need to buy. There's some free software that you might want to have on your laptop. So for instance, Java itself, the Java compiler and runtime system, is available for free from Oracle Online, and they have versions for PC and Mac. And they might have a Linux version. Anybody know? Yeah, they must have a Linux version, sure. And of course, you might want to have Emacs, the editor. You might want to have Eclipse, the interface. Well, I forget the word. You might want to have Eclipse, although I personally hate it. There's a bunch of different support software you might want to have. And that's already being discussed on Piazza, by the way. So students have already made some posts about that and where to download some of that software. Other questions? I want to get through a little vocabulary here, specifically object-oriented programming. Has some concepts that have their own funny names, and so I want to reel off some of those, tell you what they mean, and how they're going to fit with what we're going to be programming this semester. So let's start with the word object, which we hear a lot. An object is just a repository of data. So for instance, I might have a repository of data named MyList, and MyList might be a shopping list object whose purpose obviously is to record your shopping list. We also talk a lot about classes, and classes are types of objects. So, what I just said a second ago, shopping list is a class, and you can have many objects that are of the shopping list class, like one named my list, one named your list, one named his list, one named her list. Once you have objects of various classes, we want to do things with those objects, and so one way to do that is to call methods on them. Method is just another word for procedure or function. But the object-oriented weenies needed their own word for it, so here it is. And maybe the one thing that separates a method from a procedure or function in other kinds of languages that aren't object-oriented is that a method pretty much always acts upon something, usually an object, though occasionally on a class. So an example is you might write code that defines a method called addItem. And the purpose of addItem is that it adds an item to any shopping list object. But one of the interesting things about methods is that they don't necessarily just apply to one class of objects. You might have an add item method that applies to a whole bunch of classes of objects that represent lists. So I could have add item that works on any kind of list, a shopping list or a laundry list or whatever kind of list you want. And the way that we achieve that is through another mechanism called inheritance. And the idea of inheritance is that a class can inherit properties from another class. And the class you're inheriting from is usually considered to be the more general class. The inheriting class is usually considered to be a more particular, a more defined class. And to give an example, a shopping list can be a class that inherits all the properties of the list class. And one thing it would inherit is the property of storing a list of things. Another thing it might inherit is methods that add items to that list. This leads us to what's called polymorphism. And polymorphism means that you can have one method that acts on many different classes of objects, or at least two different classes of objects. Okay, I wrote in a twist here. This is true even if the classes need different implementations of that method. And to give you an example, think about the add item method. It adds an item to a list. Well, adding an item to a shopping list is very different than adding an item to a shopping cart. You need a very different implementation to put beans on your shopping list than to actually add a can of beans into your shopping cart. But you could have one add item method that does both. It's just it operates differently on different classes. And finally, that brings us to what does it mean for a language to be object-oriented? Well, one of the funny things about object-oriented languages is that each object actually knows its own class. And that means that each object knows what methods or what versions of what methods work on that class. So a shopping cart knows which version of add item applies to that shopping cart. Now, in this list of properties I've put up, polymorphism is, in a sense, the most important one, because polymorphism is the one that distinguishes object-oriented languages from standard procedural languages like C and Pascal and Fortran and BASIC. Any questions about this? So now that oh yeah. Have what? So, not exactly. So the question is whether the previous languages have inheritance. What a lot of previous languages do have is the ability to extend a structure. So you can have an object and you can make another kind of object that's based on that object but adds more things. And so in that sense, it's just like inheritance. Where it's different is that, for instance, C or Fortran don't have a mechanism for knowing what type of an object is and knowing to call different methods or different method implementations based on the type of object. That's the part that's missing. In this example, I'm saying that yes, shopping cart is a type of list for the purposes of this example. All right, so now that the formalities are over, let's get down to Java. First thing you should know about Java is that when you want to store data in a variable, you have to declare them first. And part of what it means to declare them is, say you want a particular variable to exist so you can use it, and part of what it means is you declare what type of variable it is. So you have to specify the types of every variable you declare. And so if I may compare, in Python, you can just write a line of code that says x equals 1, and lo and behold, x is 1. In Scheme, it's just slightly trickier. You have to get all the parens right and so forth, but you can say let x be 1 and x is 1. In both cases, you didn't have to first tell the language that you want a variable called x or what kind of variable x would store. But in Java, you do. So in Java, what we've just accomplished here requires a little extra work. We're going to do it in 2 lines here. First, I'm going to have a variable declaration that looks like this: int x. That says, Java, please make for me a variable called x, and I want it to store an integer. And once you've done that, now you can say x equals 1. If you try to do the second line without the first line, you get a compiler error. Java says, variable not defined. So about this int x, I want you to know that it does 2 things. Just that one line, not even the second line. The line that says int x does 2 different things. The first thing it does is it allocates a chunk of memory for you. And that chunk of memory is big enough to store an integer, but no bigger. And in this case, Java actually has more than one way of storing integers, so we're looking at a particular way of storing an integer called the type int. More about that in another lecture, other kinds of integers. And then the second thing it does is once it's allocated that chunk of memory, it also gives it a name. So now that chunk of memory is officially named x. And so the way I will conceptualize this over and over again this semester is I will draw little boxes for variables. So this box here is the chunk of memory that Java just allocated. And since we've named it x, I'll draw a little x next to the box. And now that I've done that, I can go on to that second line of code, the line of code that says x equals 1 right here. And what does that line of code do? Well, it stores a 1 inside this box. Yes, red shirt. The advantage of manually specifying the variable is it takes a lot of work away from the language. The language doesn't have to be able to store integers one moment, floating point numbers the next moment, and strings the next moment in the same variable. And that can give you faster, more memory efficient code. Mm-hmm. What was your example again? You do, right.
If you try to just set x equal 1 without first defining int x,
Compiler error.
versus if you just try to, versus if you declare int x, but then you try to use it before the data value.
If you declare it, but you try to use it before it's declared, then you still get a compiler error.
Well, no, what I mean is like, for instance, you said int x,
Mm-hmm.
and then you like wanted to say print x plus 3,
Yeah.
but x has no value.
Okay, that's another situation. So the question is, what if you say int x, and then you try to print x, but you haven't assigned x a value? So there are circumstances where Java will catch that, and there are circumstances where it won't. But in that exact example, the compiler will say variable used without being initialized and give you a compiler error. Mm-hmm. So I believe that when you add a float to an int in Java, that Java promotes the int to a float automatically. But I would have to double check whether it does that in all circumstances. Yeah,
Instead of writing it in 2 lines, can you just write int x equals 1?
you sure can. Int x equals 1 is a one-line way to do this. And I'll come to that. I want to talk about another variable now. We can also have variables that are not just simple things like ints, but variables that are used to reference objects. So int is what's called a primitive type. It's just a box that stores a number, but when you want to do something more elaborate in Java, often you need to store objects. And there is a variable, a special kind of variable called a reference, whose job is essentially to point to an object. Now, before we can talk about how you reference objects, we need some classes to work with, classes of objects. And there are 2 ways to get classes of objects. And one is use one that's been defined by somebody else. And as it happens, Java has tons of predefined classes that are built in. Specifically, there's something called the Java Standard Library that comes with every Java compiler. It's a standard part of it and has all kinds of classes you can use to accomplish all sorts of things. But when Java's classes aren't enough to accomplish what you want, you can always define your own. Today we're going to stick with option 1. On Monday we'll learn how to define your own classes. For now, let's consider one of the most commonly used built-in Java classes. It's called string. And so I'm going to declare a variable called myString, whose type is the built-in string class. So again, string is built right into Java. However, when I say string myString, that does not create a string object. What it does is it creates something called a reference variable that can point to a string object. And so I'm going to draw it as a box. So there's our variable. It's called myString. Again, remember this box is not an object, it's just a variable. Initially, this reference doesn't reference anything. It doesn't point to an object yet. So we're going to write an assignment statement that makes it reference an object. To do that, first we have to get a hold of an actual string object, and so we're going to create one. And I'm going to do that with this following line of code. MyString equals new string, and I need an open parenthesis and a closed parenthesis at the end here. So this is an interesting line of code. It does a couple of things in 2 steps. So let's look at the 2 steps of things this line of code does. There's a certain sense that this kind of gets run from right to left. So the first piece of this line of code that actually does anything is the part that says new string. And so Java executes that, and it is called a constructor. And its job is to construct a brand new string object. And in this case, it's an empty string object that has no characters in it. So it's a blank string. The second thing is that there's the assignment statement, which comes down to an equal sign with something on the left that we want to store a new value and something on the right that is the value to be stored. And so this causes my string to reference that new string object. So the constructor essentially creates this empty string object. And then the assignment takes a reference to that object and stores it in the box called myString. And the way I'm going to draw that is I'm going to draw an arrow that starts in the box and points to the object. And this is my way of saying I have stored in this variable a reference that points to that object. Basically, it's the memory address of that object, sort of. I'll tell you what it really is at the end of the semester. Any questions about that? Mm-hmm. It is the whole new string part. So, well, let me put it this way. You could say this part I will say is a constructor call. If you just write string parentheses by itself, you might say that that's the constructor, or you might, just to be complete, say it's the constructor signature. Other questions? Mm-hmm. Oh, so you can do that in Java. What happened? It is perfectly valid to have a line of code that says new string, like that, and then Java creates a new string and then throws it away because nothing points at it. One other note I want to make, something that differentiates Java from one thing that differentiates Java from Scheme and Python is that Java programs must be compiled before you can run them. As you will find out in your lab tomorrow or Friday. And so, just so you know what's going on, if you take a language like Python or Scheme, when you're prototyping a program, what you do is you just take your Python program in a py file, and you type in Python and the name of your program, and you get your answer right away. Not so with Java. In Java, there's an extra step. You've got your Java program. And the first thing you have to do is you have to compile it. Now, let me say, for those of you who are using an IDE like Eclipse or Xcode or whatever, I do think you should practice at least a little bit just compiling and running Java programs from the command line, the Unix command line, so you know how to do it, because there will be times when you need to be able to do it, even if you're using an IDE most of the time. And it's good to understand what actually happens, that you're compiling these Java files, and the result of that is you get these class files. The class files contain what's called bytecode, which is not quite machine language, but it's a much lower level code than your original Java program that the Java virtual machine can read and understand very quickly. And then that's what gets executed. And then the second step is you run a program that's just called Java on the class files, and that's what gives you your answer. And what Java actually does is it runs what's called the Java virtual machine. Or JVM for short. And that goes through and interprets your bytecode and gives you your answer. There do exist as well compilers that will take Java directly to machine code, though they're not used as often. And of course, Python also has a compiler that can compile down to bytecode, so it runs faster. But you don't always have to use the Python compiler. You do always have to use the Java compiler. Questions about that? The difference between a compiler and a virtual machine. A compiler's job is to look at a piece of code and either convert it to the machine code that your CPU knows how to run, or to convert it to at least a lower level language that can be run much more quickly and efficiently than the original program, which is what is happening in this case. The Java virtual machine is what actually executes your program. It's not compiling at all. It just takes something that's compiled and actually runs it and does the work, does what you told it to do. Other questions? Yes? Between an interpreted language and a compiled language? Well, usually when people say compiled language, the language is actually compiled right down to the machine code that the CPU runs. Java is actually an exception to that, but usually that's what that means. A compiled language usually runs a lot faster than an interpreted language. There are advantages to having an interpreted language, like sometimes you can actually change the program while it's still running, and your changes just immediately take effect. So I want to go deeper now on constructors and objects. So let's try out several different string constructors. So we've essentially seen this. Step one, which declares a string variable. And steps 2 and 3, which construct a new empty string and assign it to S. And so let's go ahead and do that. Here's what those 2 lines of code do. I now have an object on the right, a variable on the left that points to that object, that references that object. And I want to point out also that I have the option to combine those 2 lines into a single line of code. So I could have done all of this with just this one line, as one student asked a little while ago. So this essentially is just steps 1, 2, and 3 combined. You can just do the declaration and the assignment all in one line of code. But I should mention that you can only declare a variable once in a method. So if you're doing multiple assignments to the same variable, you only declare it the first time. Once I've declared it, now I can assign it a different value. So let's suppose I write this line of code. What this line says is, I want to take this string yao and now I want to make s point to that instead of pointing to the empty string. So one thing that's interesting about this is that when I write that string yao in my Java program, that's actually a very special constructor that constructs a string that says yao. And once this line of code has constructed that string, then we assign a reference to that string to s, which overwrites the old reference. So the old reference gets replaced by a new one. It depends. There might be some other variable somewhere that also references that same object. So that object at the top, if there's something else that's pointing to it, it might survive. But if there's nothing else pointing to it, then eventually, not right away, but eventually, the garbage collector will probably figure out that nothing points to that object anymore and clean it up, reclaim its memory for new objects. We'll talk about garbage collection at the end of the semester, by the way. Mm-hmm. If you try to assign this new information without what? So are you saying that I write string s equals yao? That works. That works fine. Mm-hmm. So another thing I can do is I can declare a second variable called s2, which is also of type string, and I can assign it whatever is stored in s. So I'm going to draw it over here. Here's my new variable. It's called s2. And what this line of code does next is it looks in the box called s, it sees what's inside that box, and it copies it into s2. What's inside the box called s? Well, what's inside the box called s is a reference that points at this object. So I'm going to copy that reference into the box s2, and now s2 will also have a reference that points at the same object. So it's not just that s and s2 now both point at the string yao, they point at the same object. Now, it doesn't always have to be that way. For instance, here's another thing I can do. I can write the line of code that says s2 equals new string s. Now, this is an interesting example because I'm now using a different string constructor. It's not the same string constructor I showed you before, although it looks pretty similar. It is a string constructor, so it says new string, but it takes a parameter, and that parameter is the reference s. And this constructor behaves in a different way. What it does is it looks at the string object that s is pointing at, and it makes a copy of that object. So this constructor is going to make a new string that says Yao. So it's the same string, the same word as the other object, but it's not the same object. It's a different object with the same word. And now S2 gets assigned a reference to that string and doesn't point to the old string anymore. Meanwhile, S still points to the original string. S2 points to the new one. They're identical, but they're different objects. Mm-hmm.
The first example, was S2 referencing S1, or was S2 referencing S, or was it referencing what S was referencing? So, for example, if you change what S equals, would S2 change as well?
In the first example, if you changed what S equaled, then no, S2 would not change as well. Mm-hmm.
What happens if you switch the s equals to Yao and the string s2 equals to s? So you first have the string s2 equals to s, and then change the s.
So if you first do something like string s and then string s2 equals s and then s equals Yao? That's what you mean? All right. What will this do? Well, first it's going to create a variable called s, and now we need to know what's in that box that we haven't assigned anything to. Well, if Java will compile this at all, which it might not, then there's nothing in this box, but nothing means there's a special kind of reference called the null reference, which doesn't point to anything in particular. And so then when you say the second line of code, it will create a variable called s2, and it will copy what's in the s box to the s2 box. So now you have a null in the s2 box, which you already had, but now you've made sure. And then finally, you will set s equal to Yao. And so we overwrite the null pointer with a pointer to that new object we've just created, but S2 still has the null pointer in it. It doesn't change. Mm-hmm. All null pointers don't point to anything. They all point to the same nothing. Mm-hmm. If you assign, say what again? Are you saying if I do this? Or did you have something else in mind? If you do this, then, Well, here's where you get into Java arcana. So, as it happens, Java has kind of this secret hashing operation built in where when you specify a string that, like that, it checks if such a string already exists, and if it does, it reuses it just to save memory. This is not something people actually need to know for this class because, as far as I'm concerned, it's too technical and irrelevant. But in this particular case, to save memory, Java will make S2 point to the same object. Pardon me? So if you do new string S, this forces Java to make a new object. So this constructor forces Java to make a copy of this string that's distinct from the original object. And so it does not allow Java to optimize memory by secretly reusing the same object twice. This is a way to force Java to make a new copy of the same string. In the back here. Mm-hmm. Different objects. So if you say S2 equals S, so now S2 is pointing to the same object as S. And then you now assign S to point something different. So create a new string, hi, and S points to that. S2 still points to Yao. So changing S so it points to hi is not going to change S2. This will take too long. I want to go back to this line of code right here. And the reason why I want to go back to this line of code is because it's a relatively short, unassuming line of code, but it's actually doing a lot of things. And I want to spell out the process for you once so that you understand every step of what's going on here. Java does at least 5 things when it executes this one line of code. First of all, it looks inside the variable s to see where s is pointing. It follows that reference and it finds a string object there. Then it reads the characters in that string object. Then it creates a brand new string object that stores a copy of those characters. And then it makes S2 reference the new string object. So that's a lot of stuff going on. And in a sense, again, that line of code is being executed from right to left, because step 1 starts here. It says there's a variable s. I need to pass S as a parameter, so I better figure out what S is and what it points to. And then it calls the constructor, which actually reads the string, copies the string, constructs the new object, and returns it. And then finally, the last thing that's executed is this equal sign here, which makes S2 reference that new string. So there's a lot going on in there. So coming back to what we've seen so far, we have seen 3 string constructors so far. There are more, but let's just consider the 3 we've got. We've got new string with empty parentheses, which constructs an empty string. Meaning one with 0 characters. In the string. We've seen that if you just put some letters in quotes, Java considers that to be a special string constructor. And the third one we've seen is we say new string and we pass it a variable. We pass it a variable of type string. So that's a reference to a string we're passing. And this one therefore takes a parameter. You've got to have a string parameter that you can pass in to call this constructor at all. And then that constructor makes a copy of the object that S references. Now, as a general rule, constructors always have the same name as the class that they construct. With one exception, which is that very special constructor where you put stuff in quotes. That is the one and only example in Java of a constructor that's not actually named after its class. But that's the only exception. Now, you'll observe that the first constructor, which takes 0 parameters, and the third constructor that takes 1 parameter, they're 2 different constructors that do different things because they've been passed different parameters. There are actually a lot more string constructors that are all different, and which one you call depends on what parameters you pass them. You might pass several different parameters. You might pass an int or another kind of object, and you wind up with different results depending on what you pass in. There is an online Java API that you'll learn how to use in lab where you can look up these things and find out what the rest of the constructors are. All right, now I want to look at some other methods. Constructors are methods, but now I want to look at some methods that are not constructors. Strings have a method called toUpperCase, which takes a string and gives you a new string where all the lowercase letters have been changed to uppercase. So, using this in the previous example where S was still pointing at Yao, I'm going to get a variable called S2. And when I call S.toUpperCase, that's going to create a new string that looks like Yao in all caps. And then we do the assignment. So that S2 points to that new string. Mm-hmm.
Any case deletion, I'm assuming it has no effect on punctuation marks or any non-character, any target letter.
It doesn't have any effect on anything except lowercase letters. Another example is the concatenation operator. Which allows you to concatenate two strings together. So this will give me new variable s3. The concat method will give me this string here. And then we do the assignment. Concatenation has a shorthand. Because it gets used so often in Java, concatenating strings together, Java will allow you to just write s3 equals s2 plus. So essentially, if you say in Java, I want to add two strings together, Java will convert that into a statement like this that calls the concat method for you so that you don't have to. Mm-hmm. Missing a what? Oh, that's true. There should be 3. Thank you. Question there? Okay. Guess not. In the back? It sure does. Yep, good catch. So right here, when I have those 2 exclamation marks in side quotes, that is a constructor. And so it's constructing a string object with just 2 exclamation marks, feeding it to concat. Concat uses it. When concat is done, there is no longer anything that points to that string, and so that string drifts off into space and eventually gets garbage collected. Mm-hmm. Yeah, you always use double quotes. Single quotes are for characters. Mm-hmm. No. Nope. It does return a new object, yes. So concat does not change the original object, and neither does toUpperCase. They both return a new object. Neither of them change the string. Mm-hmm. It's not a capital C. I think it's stupid, but I didn't invent the language. So yeah, it's an uppercase U, but it's not an uppercase C. So go figure. I guess that's why they went into computer programming. They couldn't spell. And of course, you can chain these things together if you want. So I'm taking a string and I'm calling the concat method on that string with a parameter that is another string. And once that gets computed, that's going to give me a string, and I can call another method on that collective string and concatenate that another string to that as well. So you'll notice I'm chaining method calls together here. I call concat on that string over there, and then I call concat here on the string I just made with concat. And again, another way that you can write this as shorthand in Java is like that. So as I just pointed out, in all of these examples, the strings that I'm calling these methods on did not change. One moment. Yeah? No. Oh, I'm assuming S3 was already defined there. So yeah, you do need string in front if it isn't already defined. Mhm. Well, it depends which one you're talking about. Let me get rid of that because that's just confusing. Oh. Mm-hmm. Oh, yeah, yeah. Gotta fix my notes here. Now, there's a reason why none of these strings are changing, which is that in Java, strings can't change. In that respect, strings are a somewhat special object in Java. We have a technical term for this. We say that strings are immutable. Once you construct a string, it can never change. You can't go back in and change the characters. If you want to change the characters, you have to construct a whole new string object and replace the old object with a new object. You can't actually go in and surgically change the old string object. However, that is particular to strings. Most objects in Java, you can change their internal fields. Strings are an exception. Mm-hmm. I honestly don't know why the Java designers decided to make strings immutable. Probably for efficiency. Probably they figured that the base string class, they should just be able to do everything as fast as possible. And if you can't change it, that removes a lot of, or that creates more opportunities for optimization. But I'm just guessing. Mm-hmm. Say that louder. No, you can do that. I mean, if you write something like S2 equals S2 plus S2, then Java will go ahead and make that combined string. And then it will replace the reference in the reference variable S2 will then point to that new string. The old one will still be around, but nothing will point to it anymore. I want to talk a little bit about I/O classes and objects so you can do your homework for next Wednesday. So there's a class called System. It's built into the Java standard libraries. You always have access to it. And it includes many things for user interaction. For those of you who are familiar with Unix input and output pipes, the rough equivalent to that is system.out and system.in. System.out is a print stream object, where print stream, again, is a standard Java class. And its job is just to give you a connection to your computer screen. And it just outputs text to the screen, which means you have to be running something like an Xterm or a console window that can take text from your Java program and print it for you. And again, remember that when I say something like system.out is a print stream object, that's really shorthand for saying system.out references a print stream object. So there is some variable called out, and out is in the class system. So we have to write system.out when you're writing code that's not in the system class to refer to that variable. And there is a print stream object that contains all sorts of secret knowledge for getting access to your computer screen. And system.out references that object, or points to that object. But I'm just going to start saying as shorthand, system.out is a print stream object, when I really mean it references a print stream object. And likewise, system.in is an input stream object. Yet another class defined in Java. And its purpose is to read from the keyboard and again, unless you can find a dumb terminal, you're going to need something like an Xterm or a console window to actually feed your keyboard input to your Java program. But having done so, with Xterm, for instance, you can read those keystrokes with the input stream object. But using these things is kind of complicated. You have to know what methods to call in order to get access to them. And it turns out you can't just directly read a character from the keyboard with input stream. You have to construct some other objects that know how to buffer those characters first. So, for instance, suppose I want to read a line of text. Like I want to be able to type in a line of text, hit enter, and have my Java program read and recognize what I just typed. So system.in, or any other input stream object, does not have a method that reads a whole line of code directly. There is a method called readLine that I would love to use. But it's not defined on an input stream object. It is defined on another kind of object called a buffered reader. And my goal is to take my input stream object, system.in, and construct a buffered reader object on top of it that can read from it. And so there's a little weird line of logic you have to follow through the Java API to figure out how to do this. And so the first question is, how do we construct a buffered reader? And the answer is there's a method that will allow you to do that if you have an input stream reader. Well, oops, I didn't say input stream, I said input stream reader. How do I get one of those? All right, how do we construct an input stream reader? There is a method that allows you to construct one of those if you have an input stream. And how do we construct an input stream? Actually, we don't have to. We've already got one. System.in is an input stream. And so, again, the question is, how do you figure all this out? Well, the answer is going to be that you go look at the online Java API that tells you all about the standard libraries for Java, and you search for the particular things you want until you find them. And specifically, the Java API has many pieces, but in particular, there's a library called java.io where you can find this stuff. And so then the next question is, why all this fuss? Why do you need to go through these different objects just to be able to read a little bit of text from the keyboard? Well, let's start with input stream objects. What an input stream object does is it reads raw data from some source. So essentially, the input stream system.in knows how to reach your keyboard and get bits from the keyboard. So it's got raw data, but it doesn't know how to format that data. We need a different kind of object that knows how to format those bits and turn them into characters and lines. An input stream reader is the next level of our hierarchy, and its job is to compose the raw data into characters. And by the way, characters in Java are 2 bytes long. They're generally 2-byte Unicode characters. So now you've got characters, but we're not done yet because all that gives you is characters. It doesn't give you a whole line. A buffered reader is a reader that actually knows how to take characters as input until you hit the return key and then composes them into a line of text that you can read all at once, which is usually what you want with simple Unix command programs, or if you're writing a simple Unix command program. So a buffered reader's job is to compose those characters into entire lines of text. Yes, sir? So it depends. Part of the point here is that you can plug in many different objects that are designed to read input from all kinds of different devices, not just keyboards, but anything. And those are all going to be device dependent. So it will vary depending on which particular reader you use. It will vary from one computer to another, from one operating system to another, from one Java library to another. All of this is deliberately kept hidden from you. So the point is, there's an input device. You're not supposed to know how to get bits from it. Someone else is taking care of that for you and can change it at will. So an important question is, why are we dividing these things into 3 different classes? Why don't we just have one class that takes all the bits from the keyboard and composes lines of text out of them? And the reason is because object orientation encourages you to write your code into decomposable pieces so you can take any one piece and replace it with a different piece. So for instance, I can replace my input stream with something that reads bits not from the keyboard, but from the internet, or from a remote device, or from any of 1,000 different input devices. I can replace my input stream reader with a different input stream reader that composes bits into floating point numbers or into some alternate characters, not Unicode, but some other character encoding, or that does 4-byte characters or whatever. And I can replace the buffered reader with something that treats the escape key specially, or otherwise takes your characters and does something special with them. And any one of those parts can be swapped out, replaced with a different part, replaced with a new, better program, while keeping the other ones intact. So now that we've gotten that far, what I want to do is I want to give you a complete Java program so that you can see what an entire program looks like. And this is going to be a really simple program. It's just going to read a line of text from the keyboard and print it out on the screen, basically echoing its input. So the first line of our Java program is going to tell the Java compiler that I need, or I want, all of the classes in the java.io library. And I need that so I can get at the buffered readers and the input stream readers and the input streams and the print streams and so forth. Once I've imported any libraries that I need to use, then I'm going to declare a class, because every program has to be inside a class. And here, I have to give my class a name, and this class name is also essentially the name of my program. So I am creating a program, and the name of my program is SimpleIO. The program is going to have one method that I'm going to write, it's called the main method. The main method is the first method that executes when you call a class from the Java program. So if you say Java Virtual Machine, please run the SimpleIO program, the Java Virtual Machine looks for a method called main and starts there. That's the first thing it executes. And here is how you declare the main method. And there's going to be lots of stuff you're not going to understand here. Don't worry that you aren't going to understand all of this right now, because we're going to spend the next 3 or 4 weeks learning what this means. So here I'm declaring the main method as a public static void method, which takes one parameter, which happens to be the command line arguments passed in from Unix, and I'll show you how to use those a few weeks from now. And this program also has to be able to throw exceptions, because pretty much any program that does I/O can have bad things happen. So that whole line is just a very complicated way of saying, I'm about to define a method that does something. And now I can start writing actual lines of code that do things. So the first thing I'm going to do is I'm going to declare a variable that I can use to store a buffered reader. And I'm going to call it keyboard. And I'm going to assign it a brand new buffered reader object by calling the buffered reader constructor. In order to construct a buffered reader, I need an input stream reader to call it on. So inside the parentheses, I'm going to create a new input stream reader. And in order to construct a new input stream reader, I need an input stream to pass in and say, I want a reader for this particular input stream. And that input stream is going to be system.in. my keyboard input. So that is my first line of actual executable code. It takes, again, this is one of those lines of code that execute from right to left. It takes system.in, our object that points to the keyboard. It creates a reader on top of it to buffer to assemble the characters. It creates a buffered reader on top of that to assemble entire lines of text. And now that we have a reference to that buffered reader, we can call the readLine method to read a line of text. And once I have that line of text, I want to print it to the screen. Printing things to the screen is usually done by taking the system.out object and calling the printLine method on that object. And then inside the parentheses, I put a string that I want to print. Well, I'm going to get a string by calling readLine on the keyboard. So again, this readLine method returns a string. That string is going to become the parameter to the printLine method, which prints that string. And then with a few closing braces, that's the end of my program. Any questions about that? Mm-hmm. Yeah, this runs exactly once. It reads one line, it prints it, and then it terminates. Mm-hmm. A few final words. To use the Java libraries, other than Java Lang, which you get for free, you have to import them. And in this case, we had to import java.io because it includes classes like InputStreamReader. And just a reminder, a Java program always begins at a method called main. And I'll see you all on Monday.